I'm having a hard time with my words today. Okay, let's talk about batteries. These are some questions I get fairly frequently, and I thought it would be a good time to talk about it and see if we can demystify some of the internet folklore that we all seem to see online. Some of the big questions are, why do manufacturers generally only recommend alkaline batteries? Is it possible to use a rechargeable battery for your preamp in your bass? How long will my battery last, and how often should I replace it? And the big one is, particularly from folks who are coming over from passive instruments, is a fear about having the battery die during a gig. So let's dig into this a little bit, and hopefully we can answer these questions. So we've all experienced sudden battery death before, whether you're getting in your car going to work, your cell phone dies on you, or if you're using a wireless at a gig and your wireless transmitter dies. This fear translates very easily into questions about your instrument if it's powered by a battery, particularly if you come from a history of using a passive instrument. That fear of it just dying during a show is a very legitimate question. There are two differences there. One is, and the biggest factor, is the current draw. Most of the times when we have these events that kill our batteries quickly, we're talking about things that are drawing a lot more current. The LHZ Preamp is a very low current draw preamp. It draws less than 1 milliamp, which is almost the same as if the battery is just sitting on the shelf unused. It's very little current draw, and this greatly impacts how the battery discharges over time. So we can look at this. We'll pop over to the computer and we'll take a look at what the discharge rates are for different types of batteries, and we can answer some of these questions. So what we're looking at right now is a chart showing the battery voltage over time for an Energizer 522 alkaline battery. This is just a standard alkaline battery. Battery capacity is 565 milliamp hours, which is pretty typical. And we're looking at this curve assuming two things. The preamp draw is 1 milliamp, and this is normal for an LHZ preamp with active pickups. And I'm doing this assumption based on 15 hours per week of playing time on the instrument. So looking at this chart, we'll see that first thing we noticed is we have a nice gentle discharge curve. This looks a little different than the published curves you may see for batteries, which show a slightly steeper drop-off at the end, and that's because we have a very low current draw of 1 milliamp, so it's a lot closer to just the natural decay of a battery over time. So 1 milliamp at 15 hours per week, we're looking at nearly 6 months of just prime operating range. This is the area in green. Where it sounds fine, the dynamics are there, everything feels great, no problems. After that, after 6 months, we kind of fall into a zone where the battery voltage is now dropping, and it's between 8.3 and 7.3 volts. And this is the area in purple, where it still sounds fine, but you're starting to feel a lack of headroom. It'll feel slightly compressed. And this is your warning sign that your battery isn't fresh and you should be replacing it. You're not going to notice it out in the crowd. Audibly, it's still going to sound fine. It's just going to feel different. You got about 2.5 months at that range before it degrades even further into that 7.3 volts down to 6.3 volts range. And this is where you start hearing some artifacts. You're going to hear some overdrive and clipping as you're really leaning into the preamp, and the impact is starting to be audible. In a mix, it might not be noticed out in the crowd with the full band playing, but you're definitely going to hear it. You have another 1.5 months at this range, and if you choose to ignore it still, you're going to end up in this last range where it's under 6.3 volts, and this is where it's really going to start sounding bad. You're going to get distortion, you're going to get overdrive even playing at a moderate level. But even so, you can still run this for a few weeks before it finally dies. So you have a lot of warning before you actually have a dead instrument. So now let's flip over and look at a rechargeable battery. Now, a rechargeable battery has two different things that are immediately apparent. First, the capacity is less than your alkaline battery. But on the flip side, it'll stay closer to that 9-volt level before it finally drops off. And this is kind of what we see, a flatter line here and then a rapid drop off at the end. So with that shorter capacity comes a shorter playing time. So with the same parameters of a 1 milliamp preamp draw and 15 hours a week, we're looking at a little over 2 months in this prime operating range. After that, you have a couple weeks, half a month, where you're feeling compression, but it still sounds fine. And as you drop into the overdrive range, you have 2 weeks, basically, of its overdrive, and then another 2 weeks of distortion. So looking at these two charts really makes it kind of clear why a manufacturer is going to recommend an alkaline over rechargeable. One, you have a longer time in this prime operating range. With your rechargeable, you got 2 months. With your alkaline battery, you've got about 6 months. The other part is this rapid drop-off at the end is riskier for a live performer. Depending on the battery, this can sometimes be a very steep drop-off. Some of these batteries will stay right at 9 volts until the very end, and then they're done, and you really have no warning before they go. The alkaline batteries decay much closer to the natural fade-out time of a battery sitting on the shelf because you're not drawing the current from them. So you'll always have this long period of feeling the difference and then hearing a difference coming in during a performance to let you know it's not going to die on you like that. So what does this look like if we change our amount of playing time? Let's say you're a full-time musician and you're playing 40 hours a week. At 40 hours a week with an alkaline battery, you've got 2 months of prime time. If you play less frequently, let's say 8 hours a week, this time frame expands out to almost 11 months of prime operating range for your battery. So it really depends on how much you play. So what do we learn from all this? The first is we do recommend using alkaline batteries. They have a very gentle discharge curve, and you'll have plenty of warning before you even have a risk of failure. We recommend replacing your batteries every 6 months or so. Alkaline batteries really don't have a risk of dying during a gig unless you are deliberately ignoring all the signs, and you will feel those and hear those before you're even close to a failure point. And lastly, if you do want to use rechargeable batteries, just make sure they're fresh before each gig. This ensures that you don't run out to that limit where you hit that steep drop off and it dies during a show, and you should be in good shape. We hope that answers your questions. We'll catch you next time.